Okay, problem number 8. They say consider the differential equation, so that's similar to problem 1. But they don't say solve the differential equation, so I don't do anything. They're just giving me the equation. Then it says, on the axes provided, sketch a slope field for the given differential equation at 12 points indicated. So in your test booklet, you will have a picture like this. And they say sketch the slope field. Okay, sketching a slope field is really, really simple. You're just drawing a picture of what the differential equation is saying. So let's talk about what the differential equation is telling you. dy dx means tangent slope of the graph of y. So there's some graph out there, y equals something or other, I don't know what. Or you could call it f of x equals something. I don't know the equation. This is saying the derivative or tangent slope of that equation follows this formula. So derivative or tangent slope of the equation is x squared multiplied by y subtract 1. Which means on this graph of y equals something, if you were to go to, say, this point right here, we'll do the easy one, 0, 0, you plug in a 0 for x and a 0 for y. So we're finding the slope of the formula for y at a point 0, 0. And according to this formula, that means we would put in 0 for x and 0 for y. And we would find that the slope at that point is -1. That's what the differential equation is telling you. The differential equation is a formula for computing the slope of some other curve. So I'm getting puzzled looks. Let's keep talking until you're not puzzled.
Wouldn't it be 0?
Oh, how many saw the mistake? Give yourself 5. The puzzled looks were not for what I expected. Puzzled looks were because I messed up. So much better. Happy looks. Good. So we have some formula for y. The derivative formula tells us the slope of y. So on the graph of y, at this point, the slope will be 0. You want me to talk more about that? Okay, when you sketch a slope field, you're literally drawing what the graph of y would look like at different points. So this is saying the graph of y, if that graph went through the point 0, 0, at that point, the slope of y would be 0. A slope of 0 looks like this. So a slope field is a picture of slopes. It is not a graph. A graph is a bunch of dots that represent numbers. A slope field is a picture of actual slopes. So the graph of y went through that point. The graph of y would be flat at that point. Question? Please.
So we just do this for every single point? Or is there
For every single point. But what you want to, oh yeah, say, I cut you off, say it again.
No, there's no like short, you just kind of do this, what, 12 times?
There is a shortcut.
Okay.
The shortcut is to look for a pattern. So look at the equation, you can talk and then raise your hand. Like I'm going to choose an x or a y that's really easy to deal with first. So raise your hand if you can read my mind. What x or y am I thinking of that's really easy to deal with? Like mathematically, I want to choose the x or y that is easiest to work with. And then just do that first. So what's a really easy value to work with in this case? Let's go, Eli.
Y equals 1.
So I could choose y equal 1, because 1 minus 1 is 0. 0 times whatever is going to be 0. So I simply go to every dot where y is equal to 1. So hands up if you had your hand raised a minute ago. Show me. 2 points, 3 for Eli. So raise your hand if you can tell me where I'm looking now. Like what dots am I looking at? Hands, come on, think with me. What dots am I looking at, Brianna?
The 3 after 1.
Perfect. The hand signals were all I needed. So I'm looking here. How many were looking here? 2 points, 3 to Brianna. So I can draw the slope field very quickly like this. Yeah, that's, you don't want to just do them in order. You want to look for a pattern. Question? Please, Emma.
How are there two different slopes at
Take it.
0? How are there two different slopes at 0?
Two different slopes at 0. Keep talking about what you mean.
Because didn't we find that at 0, the slope is 0? So how is the slope 1?
Let me say it back to you and see if this helps.
Like why is y1?
Oh, it's not the slope that's, okay, let's back up. What this formula tells you is it tells you, like, there's some equation we don't know. Y equals something. We don't know what that looks like, but we know how to calculate the slope of this. We can use this. The slope field is saying the following. If this curve happened to go through this point, the slope at that point would be 0, so I draw a line that has a slope of 0. If this curve happened to go through this point, the slope would be 0 as well. That didn't help, Josh.
So it's just like if maybe the slope does go through that point, or the curve, then that's what the slope would be at that point.
Now let me add something that
So it's not like a definite, like we don't know where.
it is not
where
a
it's gonna
definite.
go.
Here's why it's not a definite. Don't like stay with me. This is a really good question. 3 points for Emma, 3 for Josh. Look at me. Look at me. Good work. 2 for Emma. Dang. Shoot. Ella.
Wait, why am I getting a ticket?
Because you were concentrating and I really liked it.
Yeah, call you.
Look.
I definitely didn't call you.
Focus. Come on. Focus. Huge idea. No, Josh and Emma are asking something super important. Look. You have a differential equation. The first problem we solved today was we found a solution to the differential equation, which means we found y equals something. Nod? Okay. As we were doing that, there was an unknown constant. Yes? Okay. In reality, how many different values can the constant, well, I didn't ask that very well. When you take an antiderivative, you get an unknown constant. We talked about this several weeks ago. That unknown constant could be anything. That's why, like an antiderivative, I'm saying this really badly, the solution to a differential equation is really an infinite number of different equations. Because you can actually have lots of different constants, depending on the situation. The problem we solved, they gave us a specification. It's called the initial condition, right here, which allowed us to identify a specific constant. With a different initial condition, you get a different constant. So in reality, with one differential equation, right here, one differential equation, there's an infinite number of different y formulas that will make that equation true. So Josh is on the right track. If the solution to the differential equation goes through this point, as it does, it will have an appearance like this. The tangent slope will be flat at that point. So it's possible that the curve for y here does this. It's also possible the curve for y does this. It's also possible the curve for y does this. We don't really know. We just know at that moment it would be flat. But the curve for y might not even go through this point. It might go through this point instead, because there's an infinite number of different solutions to this. I think that's what Josh was saying. I'm not sure if that helped Emma, though. Let's do another one, might help. Oh, yeah, please.
So since we found that when x equals 0, the slope is 0, can't we just say that all of the ones on the y-axis are 0?
That was exactly where I wanted you to go next. Is that when x is 0,
Then
doesn't matter what y is, because 0 squared will be 0. So the next pattern to notice is exactly what Savannah did, 3 points. And this goes back to the idea that when you're drawing a slope field, you are drawing what y might look like. You are drawing what y might look like. You're using the equation for finding the slope of y, and you're drawing what the slopes of y would look like at different points. It's totally different than graphing. In a graph, we graph dots, and every dot represents numbers. And here we're not graphing dots. We're saying if the graph of y went through this point, the slope at that point would be 0, because the equation tells us that. Question? Kind of exhausted the pattern, so now you just have to do it. So you say,
Negative 1 and 1 will be equal on the square. So two sides will be the same.
on the x value, that's very good. Because x is being squared, right here, x is, so I just plug it in if you can't see it. So I do dy dx at negative 1 comma 0. I'm going to get negative 1 squared, 0 minus 1. This is going to be 1 times negative 1, hence negative 1. That means the slope over here is negative 1. Therefore, you must draw a line whose slope is negative 1. You have to be accurate enough for the grader to give you credit. If you're really casual and you go, oh, negative 1, you lose the point. This slope field is probably worth 2 points total. So if you're casual, you've lost one of the 2 points. So don't be casual. I need a slope of negative 1. So what I do is say, well, here's the grid. So I need to follow that grid. So let's see. A slope of negative 1 would go just like that. So I literally practice. And then I move over and draw a line that has roughly that same slope. Like that.
Can you just like extend the graph?
Yeah, you could do that. That'd be fine. So Jane has a good idea. She's like, well, just kind of draw a dot here and say, I would have to draw a line like that. It's perfect. 2 points. Please, Ellen.
Can you be casual if you just like label what the slope is? Like that
No, they want to see it. So, but don't stress. Just line up the dots. Then Matt noticed this. He said, oh, okay, if you plug in a positive 1, you're going to get the same result. So let's see, that's 1 comma 0. That's going to equal 1 squared, 0 subtract 1. So that's negative 1 again. So that means over here I have a, so I just do this, L. I know that these 2 dots have to line up. So I just kind of carefully go like that. It doesn't have to be perfect, just good enough. So, Emma, please.
Okay, this might come out a little bit rude, but I don't understand why you were even doing this. Because you don't know anything about the graph. This is just saying, like, it could be this here, it could be this here, so you don't really know anything. So why are you?
I don't think it's rude at all. I think it's very accurate. But it feels like this is kind of pointless.
Yeah.
So don't take this as rude either. I want the 2 points. Yeah, so I'm just doing what they asked. A better answer, is that what Kevin said? Josh, somebody said it. Emma, a better answer is that this isn't really very helpful. What can be helpful is to use this idea with a computer. Okay? So I don't think it's a very helpful thing as far as like doing it by hand. With the computer, I can tell the computer to plot the slope field for lots of points. And I'll show you later, I don't have one today loaded, but you get this huge graph, and when you look at the whole graph, you can actually see what the original curve might look like. So it's kind of back to Parker's question. See, we're all used to, well, you're used to problems that come from books, right? That always work. In a real world situation, it doesn't always work. But a computerized version of this can help you understand what's going on, because you get so many lines that you can actually see a general idea of what this will look like. Not the best answer in the world, but it's the best we have for today. So 3 points for Emma. Question? Okay. You just keep going. Just same thing. Like if I go here, so Matt noticed very nicely that it doesn't matter if x is positive or negative, the result's going to be the same. So I don't have to calculate two values here, I just need to calculate one. So that would be like dy dx at, you don't have to show any work on this problem. I'm simply showing work so that you can understand what I'm doing. You can do all the work in your head. So this would be -1 squared, 2 subtract 1. So that slope's going to be just 1. So that means here I do a line like this, like this. Questions? When I come up here, now I have the x squared is still just 1. 3 minus 1 is 2, so I need a slope of 2. Please notice, I've got to draw this with a slope of 2, which means I've got to do something much steeper. So I'm like this. Question? Nick?
So you don't have to show that work, correct?
You don't have to show anything but the field itself.
So like if I just wrote off to the side, just like a number or two, I wouldn't make not.
Doesn't hurt anything. Yeah, they'll look at the field. Everything else will be considered as scratch work.
Okay.
Good question. 2 points. Anybody else? Look at the answer. Number 8. Points total, and then you just kind of break it down. You had to have a 0 slope at these spots. So if you have all the 0 slopes, they would give you 1 point. If you have these slopes here, that's 1 point. The second point would be having the correct remaining slopes. So
So they don't have to be as exact, they just have to be positive, negative.
well, this is +2, this is +1. So you've got to make sure that the grader can see the difference between this versus this. And I have seen slope fields where one of the slopes would be 1/2. So then I can't draw a line, like I'd have to draw a line more like that, so they can tell the difference between 1/2 versus 1 versus 2. I've not seen it get more complicated than that.